Hey, and welcome to Character Rigging for Beginners. This is part 4.1, and this just is going to explain, this video will explain constraints, what they do and the different types, the common types that there are, along with their option box settings and what some of those settings do. So, probably one of the first things that you'll do in Maya when you want something controlled by another thing is you'll start parenting things. Okay, so in this scene here, that window, I have several boxes here, and I have several NURBS curves, which are going to act as my controller. So they're all called control, and then the cubes are called controlled cube. So these curves will be controlling the cubes. So in parenting, what you would do is you would select your child, and then you would shift select your parent, and you would hit P. Right? And you can see over here in my outliner, my control 1 has a child now that is the controlled cube. Right? And so if I move this around, my cube, of course, follows around, and then I can also select the cube and move that around and still have that be a part of the controlling that with its offset. So that's probably some of the first stuff that you kind of do, and those are really handy. Everything that happens with the parent, the child gets, with scale, with rotation, all those get handed down to it. But you'll notice as we move it around that our cube, control cube, I have a rotation of 90 degrees on rotate Y there, but that was there before. But you'll notice that all the values here on my translate X and my rotate Z on the parent have a bunch of information, but then the child has nothing, right? It's inheriting it from its parent. So that information is on the parent. You don't need it. But when we get into rigging and we're doing lots of things with controls, we need to oftentimes keep these hierarchies separate, where we're not handing down scale when we don't want to hand down scale. And all of that comes all together. There's no separating that. And so just to back up here, make sure my cubes are set back to normal here. Okay, so this is our parent. Okay, this is just a normal parent, and that's a process that you would follow. If you have a lot of objects, you can select them all and select one control and hit P, and now all of these objects are children of this, right? That's pretty normal, pretty standard, okay? Okay, and that's the process that you would do, is you would select the child and shift select the parent. Okay, now when we get into constraints here, the selection order is opposite of that. And so knowing that right away really does help eliminate some of the confusion that can happen if you were to try to set up a control and you did it the same way. You'd automatically get errors there. So let's take a look at the parent constraint. Okay, the parent constraint is going to mimic and copy basically all the same stuff that a normal parent would do. So under your animation tab or rigging tab, you'll have these buttons here, and these are your more common constraints. So this is your parent constraint, this is a point constraint, this is an aim constraint, aim constraint, sorry, this is the orient constraint, and this is the scale constraint. And these are what the icons look like. But if you don't have those, or you're looking for them in the menu, it's really easy. Just go to your animation, your rigging, menu set and come up and you have the constraint and you have these constraints all here. So if we go up to that and we go to parent, we can open up the option box and we've got a few options here that we can select from. Okay, so the first one is maintain offset. This is a very common one that gets used almost all the time. It's default as to what it is, and maintain offset means exactly that. If there is a difference in your channels, in your different attributes, your translates and your rotates and your scales between the control and the controlled object, it's going to set up that relationship between the two while maintaining that difference. If you uncheck that, if there's any difference or any change between the two, then it will snap it over to what your control is doing. Okay, so in these cases, everything has the same values, right? My control 2 has a translate x of 3, as does my controlled cube 2, right? So there would be no difference if I were to select my controller and then shift select the controlled cube and I were to hit apply, and then if I were to uncheck that box and do the same thing on the next one and hit apply, nothing happens. It looks exactly the same, right? And they both are going to function exactly the same because those objects, there was no offset between the two. However, if you do have an offset, like this control 10 here and my controlled cube 10 here have different translations. If I were to do the same thing, you'll see it snap that automatically. Okay, and that's what the maintain offset does. Sometimes we want to snap stuff to the position of the controller, and sometimes we don't. Usually you want that maintain offset on. Probably about 80% of the time, you're going to have that maintain offset checked on. Okay, the next one I've never really used a whole lot, the decompose near object. Yeah, not much to say about that. In fact, the times that I have messed with it, I haven't noticed much of a difference. Yeah. But the next two have to do with your animation layers. So if you had multiple animation layers and you wanted to create a constraint for some animation, you could set what layer that is on. This scene has no layers, so it automatically selects none. And then if you do have a layer selected, the set layer to override is on there, so it will override whatever animation is in there. If you uncheck that, then it just defaults to additive. Okay, but not using any of that here, and really only if you're dealing with animation layers and you need to constrain something during an animation, is that a thing that is discussed or a concern. So, and the next is the constraint axis. Okay, so for the parent constraint, it's constraining both the translate and the rotate. Okay, so translate is set to all, rotate is set to all, and then the weight, how much influence the control has, is set to 1. So it's going to control it 100%. Right, and you could set that to half or 0 and have it be off right when you set it, but it's almost always on a 1 setting here. So there are times that you say, hey, you know, I want to constrain just all the rotation, but just the translate Y for this object. Do on this one here. And you can select just the translate Y and hit apply. And now it's only going to control it in my translate Y, but as soon as I move it on the X or the Z, I get no change there. And then it's going to move my rotation on all axes, which is what I have set. So there are times when you're going to switch that up and everything. For the sake of this tutorial, And for the beginning rigging, it's almost always going to be on the all. If you select all, it will automatically deselect those and just keep the all selected. So, but it is an interesting thing to know about that. Okay, is that you have these options and you have that ability to really lock out stuff that you need just one or two axes on, and you need to leave the rest alone. Okay, so back here, okay, so with our original constraint here for our parent constraint, you'll notice that everything is working just like our parent does, but in this case, our control object and our controlled cube are not in the same hierarchy, okay? And so that means that the things that the control is not controlling, it will have no effect on. So if I scale this, it has no effect on that cube. If I turn the visibility of this off, it has no effect on that cube. But if I do the same thing on my parented object, it's going to scale it, and because it is a child, it will disappear when I turn it off. So we'll turn these back on. Okay. The other thing that you'll notice is that on your controlled object, so my controlled cube 2 here, it has created this parent constraint node. Okay, and this parent constraint node is your parent constraint, and it does give you a couple little options in here. So kind of some of the main ones here. The known state is normal, that has no effect in blocking, or just basically different ways for it to turn off. So you pretty much always want it on the normal. The interpolation type, this deals anytime you're dealing with your parent constraint or your orient constraint, you're going to get this interpolation type parameter here. And what that is in many instances and cases, the things that we're constraining do not have the same rotation. They are set up differently. They have a lot of differences between the two. The space of where they're set up could be different and in different places, and will have different effects. So what the average is doing is, in those cases, it is basically how Maya is calculating how to rotate the object to match what your parent or what your controller object is doing. So, right now you can see, having my control set to gimbal here, that my rotation axes are both the same, exactly the same. There's really not going to be much of an issue. But what you'll see happen is that Maya is set on that constraint node with the interpolation type as average. So it's trying to average out, and that's basically what it's trying to do, is just match up the rotation so that it matches the other. So, but there will be times when you're rotating an object and you're setting the keys on your controls, you're moving it around, and you have two keys, and for some reason the object that you're controlling, even though it's a very linear motion, it's a very linear rotation, because the axes are different and it's computing on an average, it will wig out and it will twist and turn and go all sorts of funky ways, and you're like, how is this possible? There's nothing. I don't have any keys between here. My control is working right. It looks like it's rotating exactly right between the two spots, but for some reason, the object that it's controlling is going around in this crazy manner around. And the reason why is because of that interpolation type. So if you switch your interpolation type from average to either no flip or shortest, I almost always use shortest, like all the time. And when you do that, then all of a sudden when you play that animation between those two keys, you'll notice that it no longer has this flipping out action that's happening. And that's what the interpolation type, when it's going for shortest, is trying to calculate the shortest distance between those two rotations. And then no flip is causing it in instances where it would accidentally flip over when it gets to a certain point, because my, these control axes on our gimbal here may have collapsed in on each other, and when you're rotating another way, it could flip these around on the object underneath to try to get it to match. And so, yeah, if shortest doesn't work, which shortest should work like most of the time, then you can switch over to no flip, and it will eliminate that flipping that happens there. So this is, these are a couple controls here that are not in your parent constraint options, that only show up on the node, on your constraint node here, and that's kind of what they do here. Okay, and then the other one to really concern yourself about is this last one here. So right now it's saying control to W0. Okay, and what that is this is saying what is controlling this object. And in this case, it is this, it's control 2. Okay, and the W stands for weight, and the 0 stands for how many objects are controlling it. In this case, there's only one, the first one, but because in programming they count from 0 up, so your first object becomes 0, second one becomes 1, third one becomes 2, and so on and so forth. And that's what this is. So with constraints, you can have multiple objects constrained to and controlling one object. Okay, and it will give you all these. It will give you multiple options. So if I were to do that right now, and I select multiple controls and just one object, okay, I can hit apply, and it will create that constraint. And if I go and I look, it's showing me, look, here's the first one that I added was control 10, and the second one is control 7, control 6 is number 2, or the third one, 4th, 5th, all down the line. And these all have an equal weight of 1. So 1 is the highest amount. That means they're all influencing it 100%. But because there's 5 of them, that means it's really going to have 1/5 of the pull on it, because you've got 4 others that are holding it the same in that same weight value. So you'll notice as I move this up 5 in Y, this object will be at 1 on my translate Y. Okay, so you can adjust those weights. Put that back to 0. You can adjust the weights here so that they have different influences, and you can say, hey, I actually want this control 6 here. I want that to have the most influence. So I'm going to say it has 0.5. Okay, and then I'm going to lessen all of these ones so that they just add up to 1. So I know that they're adding up to 100%. So 0.5, say 0.2, 0.2. That brings us to 0.9, so we can do these last ones at 0.05 and 0.05. Right, so this is going to have now the most influence on it. It follows it very closely, whereas these ones, if I move it, it follows it very slightly. Okay, move this a ton and just a little bit of motion there. This one has a little bit more, but again, the most comes from the middle. Okay, And that is, yeah, those settings there and what they mean. But the other thing to kind of notice is that where before, if we selected, when we're parenting, if we select multiple objects and we shift select the last object, these would all become children of that. And it's the exact opposite here with constraints, is that all of these objects become controllers for the last object that you select. That's that selection order. So I'll just click that, and then to get rid of those constraints, we can just select that constraint and hit delete, and it will get rid of it. So these now no longer have influence over that object at all. Okay, so this brings up another point. When you look at a constrained object, or when you look at an object and it has a constraint on it, you'll notice that in the channel box, it has locked it. It has put blue, this blue highlighting on my translate X, Y, and Z and my rotate X, Y, and Z. And the blue denotes that there is a constraint of some type on this object, and that these values are being controlled by that controller object. Now Maya is going to make you think and fool you into thinking that I can still move a cube because it's letting me, right? Oh, look, I can move that and still have control over that. That is not true. Okay, just because it's letting you do it doesn't mean it's actually letting you do it. So as soon as I grab this control and I move it, it's going to snap everything right back to it and kind of destroy that. So it is something to know, is that you now no longer have control over the object directly. You have to use the controller object. Okay, now you can get into cases where you can turn a constraint on or off, usually through this right here. But if you were to select the object and I were to hit S to set a keyframe on it, it will set a keyframe, and now it's changed these channels to green. And green denotes that there are multiple things, multiple connections coming into play on this object. So not just one. It's changed it from the blue to the green. And that's what that means. And then it's changed the other keys to red, which just means there's a keyframe on those attributes. Okay, so the thing that it has automatically done is it's automatically giving you this blend parent, right? In this case, blend parent 1, and it's set it to a value of 0. It's basically adding an attribute that turns on and off your constraint. So at this point, it's off. So I can set it, and this has no control over it anymore. So if you have a character that is picking up, a flashlight or something, and the flashlight is sitting on the table, and then he drops the flashlight after he picks it up. So that's an instance where you would have your constraint turning on or off. The character would grab it, and then you would turn that constraint on, and then when he drops it, you could set a keyframe and turn it off in that position, and then that controller object will no longer control it. So just like this. And then it's a keyable attribute, so you can turn that back to 1, and now it's snapped back to be controlled by that. So just a couple interesting things to kind of note about that and constraints. So be very, very aware of that. So this becomes a really big deal when we are creating our controls. We do not want to lock out any of our translations or rotations or scales, things like that, on the object that we're going to be animating with. So when we're setting up some of these trickier things for constraints, we need to remember not to constrain our control. Okay, in this case, we don't want to add any constraints here, and we'll talk more about that in later tutorials. So, okay, so this is the parent constraint. Okay, it controls it like that. You can, of course, always go in and select the translate Y, and you can right-click on that, and you can actually go down and you can break your connection right here. So, essentially doing the same thing as checking X and Z here, but doing it after the fact. So now it no longer controls that on the Y-axis. Okay, so that's it for parent constraints. They are going to act just like a parent does, okay, but it keeps the hierarchy separate. So eliminating stuff accidentally being passed down to objects that should not be getting any information from this as a parent or this parent's parent. You know, this grand hierarchy of descendants can all influence objects way down the line. So, okay, so that is parent constraints and a big portion of constraints in general. So the next one is a point constraint. Okay, a point constraint, we go up to constraint and go to point options. So this does exactly kind of the same thing as a maintain offset. Okay, but this is the only constraining axis X, Y, and Z. This is just for translation. So if I select my control object on control 3 and I shift select, that's exactly the same. And I shift select my controlled cube and I hit apply, then it has shown me, okay, you're only controlling your translate X, Y, and Z, and you have a node, a point constraint node here under your controlled cube right here. And this, you'll notice right away there's no interpolation type, nothing to worry about there. You do have an offset X, Y, and Z that you can change, right? And that offsets where that is after the fact. And then you have your weight, so you can turn that constraint on or off as needed. But it will move it around, but it will not rotate it. Okay, pretty simple there. The next one is the orient constraint. And the orient does the opposite one, rotate X, Y, and Z on an object instead of the translation. So you would select your object, shift, or select your control, shift select the controlled object, and go to constrain and orient constraint. Here are the options. Again, there's a maintain offset, which is standard, and constrain all axes on. We'll click apply. Okay, so that controls all my rotation, but none of the translation. Okay, and then you have a scale constraint, and that does much exactly the same thing, right, for scale. We hit apply, it's applied it on our scale X, Y, and Z, and it's going to move it just like that. Okay, without affecting its trim. Sorry, got them both selected. Without affecting its translation or its rotation. Okay, and then the last type is an aim constraint. That's this little guy here, that target here. Okay, so if you have an object like this, and you have a control object, so what it's going to do is it's going to do the same thing as your orient constraint, and it's going to take over its rotation, but instead of it working off of the rotation of the control object, it's going to work off of its position. Right, so it's going to do this. We hit Q. We'll select our control and our controlled object and go to constrain and aim constraint right here. Okay, and we'll leave the maintain offset on, and then it gives you these parameters here. Typically your aim vector and what is default is for X, so this is X, Y here, and Z here. is going to be your aim vector, and then your up vector is usually going to be your y. Okay, and then there's a world up type, which is vector, but there's also scene up, object up, but I mean, just keep it at vector. That's pretty much what you need to know. And then world up vector is 1. And then you can switch those up and change them. And then again, you have the same options with what axes you want to constrain. So if we set that up here and we hit apply, and I move this around, you'll notice, oh, I did this backwards. My apologies. Select the controller and then the controlled and apply. There we go. So you can see it's pointing at it now, right? It's always looking at it. So we'll use this for eyes, and then it gets real weird right here. Okay, and this is when it starts doing things like this. This is when these aim vectors and the up vectors start having an effect, because it doesn't know, right when I get it right above it on the Y, it doesn't know which axes to spin on or to turn anymore. And so you get that weird twitching there that happens. So best way to see how each one responds is just change it up and try it. There will be instances where you do need your aim vector on Z, or you need it on Y for whatever reason, and so you need to change your up vector to X or to Z. All right? But yeah, best way to learn how to do it is just change the settings and try it, okay, until it's giving you the desired result. So you can see what this does when my aim vector is on the Y and the up vector is on the Y as well. Right? It's giving me some weird stuff as opposed to this one, which is pointing pretty much how we expect. Okay. And so yeah, just according to how like joints may be placed, rotation, orientation of joints will determine what type of vector you want to use for that. Generally though, you're going to be pretty safe with an aim vector on the X and your up vector on your Y, like 90% of the time. So yeah, so that is it. These are your different types that you have. Your parent, which controls both translation and rotation. Your point, which just controls the translation with no rotation. And your orient constraint, which controls none of the translation and just affects the rotation. Okay, and this is a difference between parenting as well and constraints, right? Parenting, if I were to move this out and away from my parent, it is going to rotate that object, but it's going to rotate it like this, right? It's not actually spinning on its own axis. It's basing off of its parent. Whereas here, we have moved this object away from its pivot point, but with the orientation, it's rotating it on its own axis, okay, on where its center pivot is, which is right in the middle here, okay? So hopefully that helps. Hopefully that explains a lot about constraints. And as we go through the tutorial, we're going to be using constraints a whole lot, so you'll become more and more familiar with them. But this gives you a good idea of the settings, what to look for, and what may be causing some issues in your scene. All right? Good luck.